So for a radical equation, so we're talking about where we have equal sign, it's an equation, and we have some sort of radical, square root, cube root, some sort of root. So what we want to make sure we do when we solve these is once we isolate the radical part, or one of the parts. Sometimes we could have more than one radical, so we isolate either the one radical or one of the radicals. Then we square both sides. Square, and underneath I'm going to put cube, take both sides to the fourth power, whatever the root is. Do that to both sides to cancel out the square root or the cube root, or we're just going to do square roots in this video, but the same idea would apply if we had a cube root. We could cube both sides. The one thing too, I'm going to put another little star note here. Always check your answer. I know a lot of times we solve an equation, we say, oh, we could check it, we could plug it in, see if it works. Sometimes we do, sometimes we don't, but with these we absolutely have to check them because a lot of times they don't work. And the reason is, if you think about it, let's do a little refresher back to, if you have y equals or f of x equals, let's say x plus 4, there's a lot of things that don't work in here. The domain is only where x plus 4 is greater than or equal to 0, or x is greater than or equal to -4. So anything less than -4 is not going to work in here. If I plug it in, I'm going to get a negative root. It's not a real number, so in terms of graphing it or something like that, we can't do it. So there's a lot restricted from the domain, so we need to be careful of this. So let's see. So my domain would only be from -4 to infinity. You have to watch for everything else. Okay, so that's why we always have to check our answer. So let's solve the square root of x minus 1 plus 4 equals 0. Okay, so first step, isolate the square root part. So I'm going to move the plus 4 over. It'll be a minus 4 on the other side. So now that I have the square root alone, I can square both sides. So I would be left with just x minus 1 on the left side. -4, the whole thing gets squared. -4 squared is 16. Add 1 to both sides. And I would get 17. X equals 17. So now let's check it. So the square root of 17 minus 1 plus 4 is that 0. So that's 16 squared root of 16 is 4. 4 plus 4, no, that is not 0. So this does not work. That was our only answer. So since that doesn't work, then there is no solution. No solution. There's a no solution symbol. So that equation has no solution. So let's see what this looks like on a graph. So if I put in square root of x minus 1 plus 4, so that's all I have to put. I know the equation was equals 0, but that's kind of like it's equals y. So notice what the graph looks like. It doesn't go through the x-axis. So that will happen. So notice it looks like the regular square root of x. Let's see, I could either type in SQRT, that works too. My basic square root of x, it's shifted 1 to the right and up 4, so it doesn't go through the x-axis. Now this one, let's do one where we have two parts, two radical parts. So square root of x minus 3 plus square root of x plus 2 equals 5. So first step, isolate the square root part, or parts. Okay, so right now I've got two square roots and they're on the same side. So what I'm going to have to do is move one of them over. And it doesn't really matter because these both look, the same amount of complicated. So I'm going to subtract the square root of x plus 2 over to the other side. If it was that one of them was just x, it's probably going to be easier to move the smaller one over and simplify the bigger one first. Because now I have this alone, so I'm going to be able to get rid of this square root by squaring both sides. So on the left side, I have just x minus 3. So that gets rid of that square root at least. Now with this one, now I'm going to write this out twice, a little smaller underneath. 5 minus root x plus 2, 5 minus root x plus 2, because I'm going to have to FOIL. I can't just distribute that. I'm going to have to FOIL this out. I'm going to go down a little lower. So, first 25 minus 5 root x plus 2 is my outer, minus 5 root x plus 2 is my inner, and then my last will be a plus square root of x plus 2. Square root of x plus 2 is going to just be x plus 2. Because that's squared, so that'll cancel out the square root. Okay, so now I'm going to have to work on getting this together. And then I have to work on getting that square root by itself. Let's do a little simplifying. So I've got x plus 27. Bring the left side down. So I'm going to move these over. Minus x minus 27. So actually the x cancels out. So I've got negative 30 equals negative 10 root x plus 2. Still going to keep isolating. Divide by negative 10. 3 equals root x plus 2. So now this square root on the right side is alone, so I can square both sides. 9 equals x plus 2. Subtract the 2 over, and x equals 7. Okay, so remember though, we always have to check with these. So, let's plug in my 7. So if I plug 7 in every time I see x, so I've got square root of 7 minus 3 plus square root of 7 plus 2, does that equal 5? So this is 4, square root of 4 is 2, 7 plus 2 is 9, square root of 9 is 3, 2 plus 3, yep, that works out. 2 plus 3 is 5. So I know I got the right answer, x equals 7. Now I could go over here and circle it. Okay. So let's see what this one looks like if we graph it. So x minus 3, square root of x minus 3, plus square root of x plus 2. And then that 5, I would subtract the 5 over to the other side to set it equal to 0. So notice this one. Zoom out a little. So it still looks like a square root. Shift it around. But notice that it goes through my x-intercept is 7, which was the answer we got. Because that's saying when y is 0, what's my x-intercept? It is 7.